Yes, students, we were discussing about 3D coordinate system. This, the space OXYZ, if I take this as Z-axis, this is Y-axis, this is Y dash, this is Z dash, and this is X-axis, OX, this is OX dash. This OXYZ is a space. These three mutually perpendicular lines, which are the mutually perpendicular lines XOX dash, YOY dash, ZOZ dash, divide the space OXYZ into 8 compartments. Then what they are? 8 compartments is nothing but octants. What they are? I can call this as what? It is OXYZ. Next, OX Y dash Z, OX dash YZ, OX dash Y dash Z. This is with respect to positive Z axis. In the same fashion, I can also write OXYZ dash, OXY dash Z, OXY dash, OX dash YZ. Next, OX dash Y dash Z. These are called 8 compartments. We call it as what? Octants. So therefore, in how many octants the sign of the Z coordinate is positive, X coordinate is positive, Y coordinate is positive. Yes. Now here X is positive, Y is positive, Z positive. So therefore, this corner can be divided into what? 8 parts. So therefore, 8 parts or 8 compartments we call it as octant. In this compartment, in this octant, each part is what? Component. X is positive, Y is positive, Z is positive. In this compartment, X is positive, Y is negative, Z is positive. In this compartment, X is negative, Y is positive, Z is positive. In this compartment, X is negative, Y is negative, Z is positive. We were speaking about positive Z axis. In the same fashion, we can also discuss about the negative. So negative Z axis, OXYZ dash. Here X is positive, Y is positive, Z is negative. Now here X is positive, Y is negative, Z is negative. Now here X is negative, Y is positive, Z is negative. Next, here X is negative, Y is negative, Z is negative. These 8 compartments we call it as what? Octants. Totally how many positive signs of X? 4. How many positive signs of Y? 4. How many positive signs of Z? 4. How many negatives? 4 for each. 4 X negative coordinates, 4 Y negative coordinates, 4 Z negative coordinates. These are nothing but what? Octants. Okay. Now let us find out the coordinate of a point when it is defined in a space. How to locate, how to identify a point when it is in what? Space, right? Now, let us find out the coordinates of the point P when it is defined in a what space? OXYZ. This is OXYZ. If I take this point as P of X comma Y, P of X comma Y comma Z be a point in the space. where the first member x is called x coordinate of the P, where a second member y, we call it as y coordinate of a P, where the third member z, we call it as z coordinate of a P. So therefore, now if I take this point as like this, now A, you call it as what? A, you call it as B, you call it as what? C. What are A, B, C? Capital A, B, C are the feet of the perpendiculars from a point P of x, comma y, comma z on x, y and z axis respectively. X, y and z axis respectively. So therefore, I take A, comma B, comma C are the feet of the perpendiculars. I take A as x, comma 0, comma 0. Next, B is equal to 0, comma y, comma 0. And C is equal to 0, comma 0, comma z. What we call it as A, B, C are the feet of the perpendiculars from a point P in a space on x-axis, on y-axis, on z-axis. Okay. So therefore, now these are the feet of the perpendiculars. So therefore, I can write this one as x, comma 0, comma 0. This is 0, comma 0, comma z. This is what? 0, comma 0, y, comma 0. Right? So now I can take this as what? P, OA, that is D, it's what? E, it's what? F. That is OADC is a one plane, DCEP is another plane, EPFB is another plane, and OAFB is what? Another plane. Now I want to find out the projection of P on xy plane, yz plane, zx plane. Now what we call it as ABC are the feet of the perpendiculars on xyz axis. Similarly, we can also call it as projection of P on x-axis is A, projection of P on y-axis is B, projection of z-axis what? C. Right? Similarly, I can also go for the projection of P on xy plane, yz plane, zx plane, let it be there L, M, N. Rather, we call it as xy, yz, zx planes are coordinate planes. There are three coordinate axes. One is x, y and z axis. Other one is, there are three coordinate planes. One is xy, next one is yz, next one is zx plane. Okay. Now let us take, let L, M, N be the feet of the perpendiculars from P on xy plane, be the feet of the perpendiculars, feet of perpendiculars from P to the first one is xy plane. Therefore, L is equal to x, y, 0. When the point is on x-axis, y and z coordinate is equal to 0. When the point is on what? Y-axis, x coordinate and z coordinate is equal to 0. Next, when the point is on z-axis, x, y is equal to 0. So therefore, similarly, I can also go for on xy plane, z coordinate is equal to 0. On yz plane, yes, x coordinate is equal to 0. On zx plane, y coordinate of the points of feet of the perpendiculars from a point A, x, y, z to the coordinate planes. So therefore, now I go for second one is yz plane. M is equal to 0, y, z. Next, the third one is zx plane. is n is equal to x comma y comma z. Okay, so therefore this we call it as projections, or we can call it as feet of the perpendiculars. So once again, the projection of P on xy plane is L is what? 0 comma xy plane x comma y comma 0. On yz plane M is equal to what? 0 comma y comma z. On zx plane x comma 0 comma what? Z. Yes, next let us find out the distance between LM, MN, NL by knowing the distance between the 2 points. As we know already, the distance between the 2 points in 2D coordinate system A of x1, y1, B of x2, y2 is defined as AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. In the same fashion here also you can find out. Let us see. Right. Now coming to this one is distance between 2 points A of x1, y1, z1, B of x2, y2, z2 is AB is equal to square root of x2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1 whole square. So therefore, when you know the distance between the 2 points, we can also find out the ratio points. How this is? Say for example, if I take on this only, if I take a point P, this is P of x comma y comma z. If it divides in the ratio m is to n, I can write P is a point on AB and it divides AB in the ratio m is to n. Is it internally? Maybe externally. I can go for, yes, now P is equal to, I can write mx2 plus nx1 by m plus n. Next, my2 plus ny1 by m plus n. mz2 plus nz1 by m plus n. If P is an internal point, if P is an external point, I can also write mx2 minus nx1 divided by m minus n, my2 minus ny1 by m minus n, mz2 minus nz1 by m minus n if it is an external point. So therefore, these are the coordinates of the 2 points. They divide internally and externally respectively. So therefore, when P is an midpoint of AB, midpoint always divides in the ratio 1:1. If I go for second one, if P is an midpoint of AB, then P is equal to, I can write x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. Followed? Okay, next comes to what? Another point. What is that? When P is in a point of trisection. You know already the point of trisection, the point which divides AB either in the ratio 1:2 or 2:1. Every such points we call it as points of trisection. In this this case, in the first case, once you put m is to n is equal to 1 is to 2, and in another case put m is to n is equal to what, 2 is to 1. That gives first point of trisection and second point of trisection respectively. Yes, after knowing the what, come on, the distance between the 2 points and also ratio points, let us see how we can find out the distance between the 2 points when they are defined in what, 3D space as well as 3D coordinate planes and the coordinate axis. And also what ratio xy plane divides the line joining of AB, what ratio zx plane divides line joining of AB, what ratio does yz plane divides the line joining of AB. Okay, right. Yes. Next one is ratio in which the line joining of 2 points A of x1, y1, z1, B of x2, y2, z2 is divided by first one xy plane, second one yz plane, third one zx plane. Let us see how it is. Now the proof of this one is very simple. If I take a line A of x1, y1, z1, B of x2, y2, z2, the ratio in which P of x, y, z divides AB is, let it be m is to n. We know it already. P of x, y, z is equal to mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n, mz2 plus nz1 by m plus n. First of all, I want to find out the ratio in which xy plane divides. What I do is, on x-axis, on xy plane, z coordinate of P is equal to 0. Which is z coordinate of P? No, on xy plane, z coordinate of P is equal to 0, right? So therefore, mz1 plus n, mz2 plus nz1 by m plus n is equal to 0. Which implies I can write mz2 plus nz1 is equal to 0. So which implies mz2 is equal to minus nz1, m by n is equal to minus z1 by z2, right? M by n is equal to minus z1 by z2. So therefore, the ratio in which xy plane divides the line joining of 2 points is minus z1 by z2. In the same fashion, I can also write now on yz plane, x coordinate of the point is equal to what? 0. I can also write now yz plane which divides in the ratio, that is m by n is equal to minus x1 by x2. Similarly, on zx plane, y coordinate of the what point P is equal to what? 0. So therefore I can write zx plane is equal to, in what? M by n is equal to minus y1 by y2. So therefore, the ratio in which the line joining of the 2 points A of x1, y1, z1, B of x2, y2, z2 is divided by 3 coordinate planes. First one is xy plane minus z1 by z2, yz plane minus x1 by x2, zx plane minus what? Minus x1 by x2. Here minus y1 by y2. So therefore, this is how the 3 coordinate planes divides the line joining of the 2 points in the respective ratios. Followed? Coming to, as I told, the feet of the perpendiculars from the point P, which is in space, on x-axis A, on y-axis B, on z-axis C, where A is equal to x, 0, 0, on y-axis B of 0, y, 0, on z-axis C, that is 0, 0, z. We have to find out the what? Distance between the point P to the coordinate axis. Let us see. If I go to this one is, right. Now I want to find out, you take this is D, this is E, this is F, right? So I can write the distance from P of x, y, z to the first one, x-axis. Now second one is y-axis, third one is z-axis. Now we know it already. Let A of x, 0, 0, B of 0, y, 0, C of 0, 0, z be the feet of the perpendiculars from P of x, y, z to the coordinate axis. So now I'll go for this is PA. This is a distance from P of x, y, z to x-axis. Means it's a PA. Apply the distance formula. This becomes x2 minus x1 whole square. This is nothing but, now this is P. Between this point, apply distance formula. X minus x whole square. This is y minus 0 whole square. Z minus 0 whole square. So therefore, this is nothing but y square plus z square. We call it as P. So therefore, the distance from the point P to the coordinate axis is square root of y square plus what? Z square. Next, I go to what? PB. PB is equal to distance from P of x, y, z to y-axis. This is nothing but PB is nothing but between this point and this point, you apply distance formula, x square plus 0 plus z square. This is nothing but x square plus z square. Okay. Next, PC is nothing but distance from P of x, y, z to z-axis is equal to square root of z-axis between this point to this point is x square plus y square plus 0. Y, z minus z is nothing but square root of x square plus y square. Remember, the distance from the point P, which is in a space OXYZ, to the x-axis is, square root of y square plus z square. To the what? Y-axis is what? Square root of x square plus z square. To the z-axis is square root of what? X square plus y square. Okay, so this is how you can find out the distance from the point P to the coordinate axis. In the same fashion, we can also find out the distance from the point P, x, y, z, which is in a space, to the three coordinate planes. Let us see how it is. Now, the distance from the point P of x, y, z to the first one, xy plane. Second one is yz plane, zx plane, zx plane. Now, I take let L of x, y, 0, M of 0, y, z, N of x, 0, z be the feet of perpendiculars from P of x, y, z to the three coordinate planes xy, yz, zx planes respectively. Now let us see what is LP, or else the distance from P of x, y, z to xy plane is same as PL. Apply the distance from the point P to the what? L. Now this becomes x minus x whole square plus y minus y whole square plus z minus z whole square is equal to, this is nothing but 0 plus z square is nothing but mod z. Mod z or small z, it makes no difference. If you want, you can take this as mod z. So, I can take this one as mod z. Right? Mod z. Next, the distance from P of x, y, z to yz plane is nothing but PM. Why? M is defined in yz plane. This is a yz plane. This is what? xy plane. This is zx plane. So therefore, I can write PM is equal to, apply the distance between from P to the what? M. X minus 0 whole square plus y minus y whole square. Next, z minus z whole square is nothing but x square plus 0 is nothing but mod x. Now I can write the distance from P of x, y, z to zx plane is nothing but Pn. Is apply the distance between P and N. X minus x whole square, y minus 0 whole square plus z minus z whole square. Now this is nothing but, now y square, this is nothing but mod y. Remember, the distance from the point P of x, y, z, which is in a space, to the what? xy plane is a mod z, yz plane mod x, and zx plane is what? Mod y. Now I am going to make sum of the squares of the distances from a point P to the coordinate planes. What is that? The sum of Sum of the squares of the distances from the first one, coordinate axis. Second one is coordinate planes. Coordinate planes. You know already, for this the proof is the distance from P of x comma y comma z to x-axis is equal to PA is equal to square root of y square plus z square. The distance from P of x comma y to y-axis is nothing but PB is nothing but z square plus x square. Next, the distance from the point P to the what? Z-axis is PC is nothing but x square plus y square. I want sum of the squares of the distances. PA square, PB square, PC square, add up. This is nothing but y square plus z square plus x square plus y square. So therefore, this is nothing but 2 into x square plus y square plus z square. In the same fashion, I can also write the distance from P of x comma y comma z to xy plane is nothing but PL is not equal to what? Mod z. The distance from P of x comma to yz plane is equal to PM is equal to what? Mod x. The distance from this is to what? Zx plane is equal to Pn is nothing but mod y. I want sum of the squares of the distances from the point. If I take this one as, yes, now PL square, PM square, Pn square is equal to x square plus y square plus z square. Alright. So now here, by knowing these two results, look here, sum of the squares of the distances from point P to the coordinate axis 2 times of x square plus y square plus z square to the what? Coordinate planes is what? X square plus y square plus z square. Let us find out some examples on this, how it can work out. Now what he says, the locus of the point P, which moves us that, yes, locus, what concept you made in the what? Come on, a 2D coordinate system, the same thing. What is a locus? A locus is a path traced out by a moving point with set of given geometrical conditions. Here also same, that is 2D, here also what? 3D plane. Now I want to find out the locus of the point P which moves such that the sum of the squares of the distance is equal to sum 25 from coordinate axis, from coordinate planes. Let us see how we can find out. What he says, I want to find out the locus of the point P which moves such that the sum of the squares of the distances from the point P in a space to the coordinate axis, first one coordinate axis, is some 40. Now if I take this as 40, now I can write this and this get cancels. I can write this one as x square plus y square plus z square is equal to 20 is the locus of a point. The locus of the point P which moves such that the sum of the squares of the distance from the point P to the what? Coordinate axis is what? X square plus y square plus z square is equal to 20. In the same fashion, the locus of the point P which moves such that the sum of the squares of the distances from the point P to the what? coordinate planes is also 40. Take it. Now this is equal to 40. So therefore the locus is x square plus y square plus z square is equal to how much? 40. So therefore now we come across the distance from the point P to the x-axis, to the y-axis, to the z-axis, as well as xy plane, yz plane, zx plane, and also the sum of the squares of the distance from the point P to the coordinate axis as well as coordinate planes. So this is how we extended our application from a what? Distance formula. Yes, let us have the application of on planes by using the what? Concept of distance from the point P to the what? Coordinate planes. The locus of the point P, which moves such that the distance from the xy plane is 5 units. Distance from the yz plane is 5 units. The distance from the zx plane is what? 5 units. Let us see. The locus of a point P, which is such that the distance from first one xy plane is 3 units is dash. Now if I take this as a point, this is xy plane. Now the point P is at a distance, this is a P. The distance from here is what? K is equal to 3 units. Now we know that the distance from the point P to the what? Xy plane is mod z is equal to K. What is K? 3 units. Therefore mod z is equal to 3, which implies z square is equal to 9. So therefore z square minus 9 is equal to 0 is the required locus. If I go for a second one, for yz plane is 5 units is dash. I can also write this is yz plane which at a distance of 5 units or k units. So yz plane means what? Mod x is equal to k. Therefore mod x is equal to 5, which implies x square is equal to 25. So therefore x square minus 25 is equal to 0, right? Then third one is zx plane is 9 units. Locus is dash. I can write for zx plane, this is a point P, this is K. For zx plane, mod y is equal to 9. So therefore squaring on both sides, y square minus 9 is equal to what? 0. This is how you can find out the locus of the point P, which moves us that at a distance of some unit, some distance k units, at a distance of xy plane, yz plane, zx plane respectively. Let us recall the distance from the point P to the what? Coordinate planes in another way. The locus of the point P, which is equidistant from xy plane and zx plane is dash. Now I'll go for this is xy plane. I go for what? Zx plane. Now if I take this point P from here, right? This point is equidistant from these 2 points. We know that the distance from P of x comma y comma z to xy plane is equal to mod z. The distance from this to what? Zx plane is equal to mod y. But they are equal. So therefore, mod z is equal to mod y, which implies z square is equal to y square. Therefore, y square minus z square is equal to 0 is the required locus. So therefore, this is how you can find out the locus of a point with the concept of distance between the 2 points. So therefore, we come across about the distance from the point P to the coordinate planes and P to the what? Coordinate axis, sum of the squares of the distance from the point P to the what? Coordinate axis as well as coordinate planes. Now let us find out the ratio in which xy plane divides the line joining of the 2 points under some unknowns. A of x1 y1 z1, B of x2 y2 z2, C of x3 y3 z3 be the vertices of triangle ABC, then the centroid of triangle ABC is, I can write G is equal to x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, z1 plus z2 plus z3 by 3. How, sir? If I go to this one is a triangle A of x1 y1 z1 and B of x2 y2 z2, this is x3 y3 z3, this is the centroid. Centroid divides the median in the what ratio? 2:1. So therefore, first D is a what? Midpoint. D divides in the what ratio? 1:1. So therefore, I can write D is equal to x2 plus x3 by 2. Next, y2 plus y3 by 2. z2 plus z3 by 2. D is the midpoint of what? BC. And G divides AD in the what ratio? 2:1. So therefore, G is equal to 2 into D plus 1 into A, right? Whole divided by 3. Let us see 2 into, this is x coordinate. What is the common x coordinate? x2 plus x3 by 2 plus x1 by 3. In the same fashion, 2 into y2 plus y3 by 2. This is y1 by 3. Next, 2 into z2 plus z3 by 2 plus z1 whole divided by 3. Now this and this get cancels. Therefore, this is nothing but x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, z1 plus z2 plus z3 by 3. This is nothing but the centroid of a triangle formed by the what? 3 vertices x1, y1, z1, x2, y2, z2, x3, y3, z3. Okay. So when the centroid is, when the 3 vertices are given, this is the way you can find out the centroid. When the centroid is given, one vertex is not given. In that case, by knowing the other 2 vertices, we can also find out how. So from this one, what I can write is, so therefore, now if I take this as A, x1, y1, z1, now we know that G is equal to A plus B plus C by 3. If you do not know C, I can write C is equal to 3Z minus of A plus B plus C. So therefore, by using this, when x1, y1, z1 is known, x2, y2, z2 is known, and G of x, y, z is known, I am supposed to find out the coordinate of C. I can write C of x, y, x3, y3, z3 can be written as 3x minus of x1 plus x2, 3y into y1 plus y2, 3z into what? z1 plus z2. This is how you can find out when centroid is given and 2 other vertices are given. In that, we are supposed to find out the what? Coordinates of a third vertex. Thank you.